Hello friends, in our last lecture we discussed the basics of serial communication. In this lecture we will discuss asynchronous serial communication. So as we have already discussed, in asynchronous serial communication receiver and transmitter do not share a common clock. Okay, so when there is no clock, there is no synchronization, there are chances of data error. So to remove this thing, data framing, we use the method of data framing. In data framing, the bits are sent in form of packets or frames. So to make sense of the data, sender and receiver agree on a set of rules. There are defined set of rules. These rules are called protocol. What is a protocol? It defines how data is to be packed, how many bits are there in every character, when data begins, where data begins and where it ends. Okay. So to decide where data begins and where it ends, or how the receiver will know where is data beginning and where it is ending, by using these start and stop bits. While framing the data, the transmitter will add start and stop bits with the real data, and this is called data framing, adding these start and stop bits. So in asynchronous method, each character is placed between start and stop bits. It is called framing. So what is start bit? As we have discussed, there is a fixed set of rules. So start bit is always high. Start bit is always a single bit. Stop bits can be a single bit or 2 bits. 2 stop bits can be there or 1 stop bit can be there. Start bit is always a 0, low. Stop bits is 1, high. LSB is always sent first. Okay, so these are the rules of the UART protocol, Universal Asynchronous Receiver Transmitter Protocol. These are the fixed rules that according to these rules both receiver and transmitter should work. Then only we can send or receive data efficiently. Okay. So this is the framing. This is a frame of ASCII character A. What is the ASCII value of capital A? 41. So 41 is 0100 0001. Okay. So we have to send LSB first. So this is LSB and this is MSB. So before this LSB, one start bit will be added. So this is the start bit. It is always low. And after start bit, these are the 8 data bits. And after this last bit, there is one stop bit. Okay. So stop bit is always high. We can also add parity bits with this. Okay. So before start bit, the condition is mark, and after stop bit, the condition is space. It is low and mark is high. Okay. So this is how a framing is done. A data framing is made. Okay, and then this frame will be sent serially, one by one. Okay. So this is the framing of UART protocol. It can be asked in the exams. So in modern personal computers, one stop bit is used. When transferring a text file of ASCII characters using one stop bit, there is a total of 10 bits for each character. Okay, so for 8 bits, for sending 8 bits, we have to send 10 bits. So this is one drawback. With asynchronous serial communication, in synchronous we don't have to add extra bits because there is a synchronization between transmitter and receiver through a clock pulse, common clock signal. So 8 bits of ASCII code, 1 parity bit, including 1 parity bit. So the ASCII code becomes 8 bit, and 1 bit each for start and stop. So total 10 bits we have to send. For each 8 character, there are an extra 2 bits, which gives a 20% overhead. Okay. So in asynchronous mode, we need more bandwidth. Okay, because we have to send 20% more data. So these are some units. Data transfer rate, how it is measured. One thing is bits per second, BPS. This term is not used very widely. Widely used terminology is baud rate. Baud rate. Baud rate you must have heard. Mainly we use 9600 baud rate. Sometimes these names are used interchangeably, but actually baud rate and bits per second are not equal. Baud rate is defined as the number of signal changes per second. Number of signal changes per second. So these are the standards that are used in UART protocol. RS-232 is standard. So basically these are the voltage standards. Most widely used serial input-output interfacing is standard. Input-output voltages are not TTL compatible. One bit is represented by -3 to -25 and 0 is represented by +3 to +25. -3 to +3 is undefined. So if it is not TTL compatible, how do we connect it with TTL ICs and other microprocessor and microcontrollers? We have to use a driver IC. So to connect RS-232 to a microcontroller system, we must use converter ICs, voltage converter such as MAX232 or driver IC. Mainly these are voltage converter ICs. To convert TTL logic to RS-232 and RS-232 level to TTL logic. Okay. So these ICs are commonly referred as drivers. So these are driver ICs. So this is a pin diagram of RS-232 connector, 25 pin RS-232 connector. It is called DB25. It is not very widely used these days. This 9 pin RS-232 connector you may find in your desktop computers. Okay, so this is 9 pin connector. And these are the two types of mainly communication equipments. One is called DTE, data terminal equipment. Another is data communication equipment, DCE. So DTE terminals and computers that send and receive data are terminals, and computers that send and receive data are called DTE. Communication equipment responsible for transferring the data, DCE. Okay, like a modem. Simplest connection between a PC and a microcontroller require minimum 3 pins. One is ground pin, one is transmitting pin, and another is receiving pin. So this is a full duplex kind of communication. So this is how we have to connect. So this is one data terminal equipment, this is another data terminal equipment. So ground is common. So the transmitter pin of one equipment is connected by receiver pin of next equipment, and the transmitter pin of this second equipment has to be connected with the receiver of first one. Okay. So why there are multiple pins? For handshaking. Okay. Many of the pins of RS-232 connector are used as handshaking signal. They are not supported by UART chip. UART is much simpler. Normally have 2 COM ports. Now these COM ports are replaced by USB ports these days. So this is the basic about UART protocol. Next we will discuss how we are going to implement this UART protocol in MSP430 microcontroller. Thank you.